Hello. So today it's gonna be pretty deeply architectural talk devoted to the actually evolutional strategy and have the Magento developed and still developing, so still beyond developed. So it's gonna be a talk about the yesterday, today, and tomorrow of Magento. And actually, this is the most fresh photo. I believe Ricardo did it yesterday during the contribution day when we were releasing MSI. So here it is. Yeah, so I'm Magento Architect. I work in Magento community engineering team, and I work with you actually, guys. So, and today I would not be referring to much MSI, and this is not the talk about MSI. This is actually the talk about Magento and the direction where we are going. So today we'll talk about these items. So you see that the list is a pretty long one, and we'll try to talk about all of them. So, because we have a pretty intensive agenda, let's start from the beginning. So we are starting, when we say we start from the beginning, actually we are starting from the Magento 1. And when we started the development of Magento 2, we got, because as you know, the Magento 2 appeared is not as a result of the revolution, but as evolutional changes of the Magento 1. So we got all the legacy we had in Magento 1. And Magento 1, so that's why all our issues, problems we're dealing with right now actually came from Magento 1. So we have to look back and see what we had before to understand the reasons of some of our technical solutions and technical decisions we are making right now. So Magento 1 was a classical and layered architecture, so it was almost typical three-layered architecture where there were presentation layer, business layer, and data access layer. And the classical and layered architecture is usually a compromise in the design of the data model. And the biggest disadvantage of this architecture is that it tends to the monolithical architecture. And actually, the monolithical architecture don't allow for application to be deployed as a separately by modules or by some functional areas. But the scalability of Magento 1 could be accomplished just when the Magento 1 deployed as a whole instance in particular physical or server environment. And so application has to be scaled as a whole, and we also, because all our requests, both read and writes, were going through all these layers. So we did not differentiate anyhow the read out of write request, and that's why it was not possible to scale or improve performance for particular requests, for particular type of request, because we use the same models, the same routes for both read and write requests. So we had the same resource model for processing get and for processing save or update request. That was our legacy. And working with Magento 1, you and we, as a core team, most of the time actually did not even realize that Magento is such a highly coupled system, and we have so many inter-cross dependencies between modules, between classes, and that became obvious. This became evident when we decided to introduce the dependency injection mechanism started from Magento 2.0. And everything which was not clear before became evident after that. And as you know, we have the constructor dependency. And this is the only type of dependency we have. And We have it with a reason, with a strong reason, and to provide the fair and clean interfaces in our services, in our models. And when we introduce our dependency injection to classes, we've seen that, for example, here you see the constructor of one of the model, and even by this constructor, it became pretty evident that this particular class violates the single responsibility principle, because in a desirable condition, none of the class can get so many external dependencies. So probably just introducing the dependency injection give us clear understanding that we have some problems in our architecture. And even so, we had a modular structure in Magento 1, and we had quite a lot of modulars there. And they were grouped by related behavior, but it was still very easy to violate the boundaries between the components and the business destiny of the module, and to violate this dependency, introduce unnecessary and inappropriate dependency either to module or to particular class, as you can see in this particular example. So here, actually, this is diagram of the dependencies. If I'm not wrong, it was created several years ago. It was dependency between Magento modulus, Magento 1 modulus. And so the big ball of mud, this is a pattern introduced. It is definitely not a pattern, but it's anti-pattern. And we can call that Magento 1 was, at some point of time, it became a big ball of mud because of the dependencies and how these boundaries of module and classes were violated. So when we started to work on Magento 2.0, we first of all we created a document which we called the definition of done, and the first item in this document was that all the newly created code supposed to follow the solid principles, and the first letter of solid is the single responsibility principle. And we started, so as you can see, this particular class definitely violates the single responsibility. We don't see other method, just a constructor, but even based on this constructor listing, we can see that probably it's too much dependency for one particular entity. So that's why we started to apply solid. We started to apply solid. We were pretty sure that single responsibility will get us to the desirable state. As a result of applying solid, we at some point of time we started to segregate read out of write operation. We started to follow the CQRS principle, so the query command and query separation. And after that, we decided to apply it from classes level, we decided to apply it to the architecture level. So we decided to apply the CQRS, so the command query responsibility segregation. So that's this kind of CQRS principle, but applied to the whole architecture, but not on the level of one class. And changing the way of how we write the code, changing the way how we group the code on a modular basis. We currently decided to resync the modularity principle and how we build modules in Magento, and what code we put into these modules, and how and what dependencies modulars supposed to have in a system. So we decided to reconsider all the modularity approach we currently have. And when we are talking about the modularity, because Magento 1 had a lot of modulars, but when we are talking about the modularity, first of all, we need to consider the domain-driven design and the bounded context. I believe that many of you visited and been during the Ricardo presentation where he describes the bounded context of the especially catalog and the inventory. So the idea of the bounded context, so the bounded context probably is the most important part of the domain-driven design as an approach. And the bounded context actually, so any sophisticated business domain consists of a bunch of the bounded context. And bounded context contain models or another context inside. And the main idea of having the bounded context is to have the particular ubiquitous language inside this bounded context. Because in different bounded contexts, the same thing could be called differently, or even having the same name, it can represent different state, or has a different number of attributes, or provide different behavior. For example, the product in a catalog would be will have a totally different meaning from the inventory point of view, because we don't need any knowledge regarding the media data of the product, regarding the many of the attributes which the catalog is supposed to know about. And when we're talking about the bounded context, people usually a little bit frustrated to think what exactly we mean. Because many people start thinking about kind of that module is a bounded context. But this is currently wrong, because module, so we have quite a lot of wrong dependencies as a result of our legacy code. So here on this particular image you see that how we see the bounded context for particular components. For catalog, for shipping, for pricing, for inventory. So this is a group of modules. Moreover, you can see it here that some of the modules come from the Magento Community Edition, others come from Enterprise, and others come from B2B, and they still get to the same bounded context, like in the case of catalog or customer. And because I'm using the advantage that I make in my presentation last, so I can refer all the previous speakers. And Ricardo provided just a good example. We deal it with when we work on a new inventory implementation. So the quantity, and it's totally different. And actually, not just quantity, but even SKU is different, because in case of inventory, as I already said, we are not interested in media data. We are just interested in the SKU. But regarding the bounded context of inventory has a reference to the entity from the bounded context of catalog. But it knows nothing about anything else except the SKU. And the main idea of bounded context that we have to protect the boundaries of this bounded context. And we should not violate these boundaries. And doing so, and actually just doing so, we can get the desirable state of our modularity. And the main idea when we are building our bounded context and when we are securing our boundaries, we build pretty isolated components, and we have another idea after that. Why not to distribute these components on a different environment, and why not to go from the state where we run all the instance of Magento, all the modules in one place? Why not to distribute it in the among different clusters, among different servers for better scalability purposes? And when we are coming to this idea, we actually, the first which come to our mind is the CAP theorem. And the CAP theorem is pretty dated one, and this is the one from the theoretical computer science, and probably the most important when we are talking about the distributed computation. So actually the CAP theorem, the CAP, it's a shortening of consistency, availability, and partition tolerance, actually says that you can choose just 2 out of 3 these characteristics. So you can choose whether consistency and availability, or you can choose the availability and partition tolerance. And there are 2 types of systems which exist. So we as the developers, and especially the developers of Magento 1, we used to work with the ACID system. So the ACID stands for atomicity, consistency, isolation, and durability. So this is what usually all the relational databases propose to us. For example, MySQL, which we use in Magento 1. So using that transaction, we can reach all these characteristics. We can get a durability, isolation, we can get a consistency, and atomicity. But all of you who stuck with a high-load project, stuck with a high-load project working with Magento 1, they know that it's pretty hard to scale the database. So you can introduce several slaves and have one master, and you can more or less scale the read operation. But it's really hard to scale the writing operation. You can end up with the schema with several masters, but this the problem which could potentially happen would be really hard to recover if you are a DBI, and because you have to make a synchronization of all that masters, and so it could be a terrible headache. So you know that's why ACID systems are not very good, even from the theoretical point of view, for the scaling. So that's why another kind of system exists. And this kind of system called BASE, which is stands for basic availability, soft state, and eventual consistency. And when we are talking about BASE, the main idea of BASE is the asynchronicity and the eventual consistency. And when we're talking about the asynchronous operation and asynchronous processing, many developers who used to write Magento 1 code, code in a Magento 1 style, when there is introducing the transaction and introducing the synchronous transaction and making sure that all the data changes apply to all the tables. So, because it's pretty natural for developers, but it is not natural for business. And there is a really good article, which is a little bit dated, but it's still very actual. And I really recommend you to read this article, which is, the name of the article is Starbucks does not use to face commit. And actually the main idea that there is a conversation pattern there. And there is, for example, if you'll discover the business model, how that Starbucks works. So there is really short synchronous interaction between the customer and the guy who accepts the order. So the ordering and paying is really a short operation which happens synchronously. So that actually the transaction when the customer would be charged. And after that, the cashier actually puts the order into the queue, which would be processed synchronously. And actually, most of the time, the customer does not wait while he's not standing near the cashier at the cash desk waiting for the coffee. He can occupy any place and just enjoy with the conversation of his friend or whoever. And after the coffee would be ready, he would be notified about that. So this is pretty typical model, which shows that asynchronous operation is very common in a business. And actually, this type of conversational pattern is quite common for purchasing scenario as well. So it's pretty true for the Amazon.com, for example, because Amazon creates the order for you when you make an order and assigns the order ID for you. And after that, all the changes you apply to that order, for example, shipment, it would be done asynchronously after that. And moreover, Amazon, if it failed to do something like shipment, it will apply some retries or compensational reservation, or eventually it will send you an update that, for example, the Amazon is not able to fulfill customer's order and make a charge back to customer's credit card. And when we're talking about the distributed system, the error handling became a little bit, not little bit, but actually became much more complicated than in the case of the synchronous system. Because in the case of the synchronous system, we are working in the scope of the one request. So the client made a request, and he's waiting for while we will process it and while we will say whether everything is okay or a problem happened. And so the client getting back the error result can proceed with another action. But if the command was asynchronous, so it's really hard to ask the part which issued this request whether they need to what to do, whether they need to retry or what. So there are several different strategies how can be the asynchronous operation handled. So the first one, the easiest one, so which is called the write-off. So if you supposed to apply the changes to several different nodes, and these nodes are on a different servers, so you can just combine these updates into one big transaction. Because, for example, MySQL does not allow you to write transaction over the changes you are going to do into several different MySQL database servers. So in this case, you can just do nothing. For example, if one transaction was applied and another transaction was just dropped. So this is the easiest way, but probably that's not the best one, especially if you're talking about the finance operation, about the money. So another thing, if we will try to retry it, retry the operation which failed on one of the server. And the third option is to proceed with the compensational transaction. And the compensational transaction is pretty tricky, but it's pretty interesting mechanism to work with. So actually, compensational transaction is like if I'm placing an order, so the system charge some particular money out of my account, let's say 10 hryvnias, and after that it's supposed to ship me something. But for example, the system charged me this 10 hryvnias, and the system eventually realized that it's not able to fulfill the order. So the system's supposed to just get back money to me. So that's gonna be another transaction issued with adding 10 hryvnias to my account. So this kind of the compensational transaction. But not all the operation support, but not actually all the operation can be compensated. And we will talk about that a little bit later, what kind of operation can be compensated and what kind of not. And another one, so you can see a lot of arrows here. So this is two-phase commit operation, and even MySQL supported two-phase commit. So this kind of coordination between system implies the existence of the transaction coordinator. So there is a transaction coordinator, and for example, there are two resources, A and B, and the transaction coordinator, let's say, ping both of these resources and say, hey, prepare, I'm going to make a transaction. And each of these resources get back and say, yep, I'm prepared, I'm ready to make a transaction. And after that, this transaction coordinator says, so now let's do a transaction. And after that, it gets each of these resources, each of these servers proceed with the transaction execution and report to this transaction coordinator. So as you can see, it's pretty pretty intensive schema, and there are a lot of collaboration between the coordinator and the two database server, for example. So this kind of mechanism are usually not used because they are really sophisticated, and if the issue, some failure happens, it's really hard to debug that, and it's really hard to debug that and also recover data. So the business transaction that spans multiple services. So what we actually recommend and what we are going to do, so we are going to implement the business transactions that spans multiple services as a saga. And the saga is a sequence of local transactions, and after completion, each of the local transactions issue some event or publish a message into the queue. And in this case, for example, if we are dealing with the order placement, actually we have several events. Like we have the database with the sales domain, and we have database with the inventory. Both of these databases represent different bounded contexts, and so we can just wrap them in the same transaction, for example. But what we can do, we can make a transaction on for the order placement. After that, we can issue an event for some customer changes, and we can make the order in some particular state, like in a pending, and do this chain of different transactions, issuing and proceeding from one state to another state with the help of events. So this looks really native to the event sourcing. And we actually already have one of the implementation of event sourcing, or as Ricardo correctly said, really similar implementation of event sourcing in a MSI, in a new inventory mechanism, which we're going to release in 2.3.0, implemented with reservations for at the time of the order is placed. And these events would be processed later. So we are just issuing quite a lot of events. And doing so, we are increasing the performance at the time, for example, of such critical operation like order placement. And all the logic, all the business logic would be proceed later, when the order would be already placed and the money from customer would be already charged. So actually, this is the main idea of the whole e-commerce, to charge money as fast as possible. And Magento provides ability for this. So, and as I said, not when I was talking about the compensation of particular operation, I mentioned that not all the operation could be compensated. So here we come to the idea of idempotence of operation and at least once delivery. So when we talk about the idempotence, so this is a property of a certain operation whereby they can be applied multiple times without changing the result beyond the initial application. So for example, just consider that like the operation like set some value to particular property. Like if you set value like x to a particular property, this operation is safe and idempotent, because you can apply this operation several times, and the state of this property would be the same. It would be x. So we would not change it. And as soon as we deal with a distributed environment, as soon as we deal with the environment deployed on a different servers, we're supposed to understand that network communication is unreliable, and we will lose quite a lot of data during the transmission data from one server to another, And for example, if you work with RabbitMQ, you know that RabbitMQ also supports at least once delivery. So what it means? That means if you put the message into the broker, the message RabbitMQ actually guarantees that this message would be delivered to worker. But RabbitMQ actually doesn't guarantee that this message would be delivered just once. It would be delivered once or many times. Because it can happen the situation when the message would not be acknowledged. So RabbitMQ would not know whether a worker accepted this message and processed it. That's why, for example, it's not recommended to put such commands like increment, because increment is not idempotent operation. So if you if you have the broker and you have a worker which make a signal to workers that some data should be incremented, you can get a wrong result, because RabbitMQ will send message to worker several times, and the worker will just make the increment several times instead of one. So making these servers, you're supposed to accept that and make all the services to be idempotent. So out of here, we come to the design principles to follow. Here, by the way, is a QR code, which leads to probably one of the most important design documents right now, the document created by Anton Krill. So this is design proposal for modularity. And actually here you can see the list of most important design principles to follow. So all the operation must be idempotent. Saga should be used for consistency of distributed operation. All new service contracts should expose asynchronous APIs. All new state modifying operations should expose bulk APIs. All service operation must be stateless, and there must be no data dependency between services. So here is pretty interesting item regarding the new asynchronous APIs. So Magento always respects backward compatibility, and we are not going to break our existing service contracts. And and we have a way to support existing service contract, introducing the cross servers communication. So for example, we could introduce invokers, which will just swap our service contracts with the proxies, and depending on the configuration, they can call service in the scope of the same system process scope, or issuing the request via inter-process communication like MessageMQ, REST request, or SOAP, GraphQL, whatever. But still, the issue in this case is that our APIs, our existing service layer APIs, are synchronous by its nature. So we don't respond with some kind of promise, but we respond with particular result. So this still introduces an issue for us. That's why we, in a desirable state, all the newly created API in future would be probably follow the asynchronous principles. So the idea of the response would be some kind of promise. So the service layer, I believe all of you already aware about the service layer in Magento 2. So every module, not every module, but at least every functional area has a service layer. And service layer introduces the bulk of the PHP interfaces, which marked with the API. And actually, this interface is supposed to be used as a cross-module for the cross-module communication. And all other models, classes, consider it as a private implementation. So, but this is how service layer looks like now. So we introduced this service layer, but because we had this legacy heritage, we still have quite a lot of dependency from model to model and from presentation to model. Especially there are a lot of dependency from presentation to model. That's why we're still not able to change freely our private implementation, because there are a lot of dependency in the private implementation. And that's why we are making our modules more granular. And this is how, for example, we have now like a monolithical model catalog, but the monolithical model catalog is supposed to be split on many blocks responsible for particular area. So they're gonna be admin endpoint, they're gonna be front-end endpoint, they're gonna be entry point for the GraphQL, they're gonna be API segregation here. So, and these small blocks are easily switchable. So if you need just substitute a particular implementation, you just substitute with your particular module the one which we have. So it's much easier to substitute small blocks than the big ones. And here the example of this approach applied in inventory. So for example, you can see that we usually have like 4 modules. The one which just declare APIs. Another one is the contains the private implementation. So the classes implemented APIs declared in the API module. So for example, we have inventory and the inventory API module. Also we have the admin UI and frontend UI. So we make this segregation because our admin UI and frontend UI supposed to be very different. They will use even totally different architectural stack. So in your admin UI, you will still probably use the admin component, UI components, while on a front-end UI, you will use the PWA, or you will use React, and you will issue the queries with the GraphQL. And also, when we are working with Magento, currently we always follow the principle the headless first. And the idea of the headless first approach, you can see it here from my handwritten diagram, that you can, and this is really clear with the inventory, especially because, for example, when we're talking about the MSI, so MSI always supposed to be integrated with ERP system. For example, MCOM. And MCOM, when it's integrated with ERP system, usually this ERP system is considered as a source of truth. And the source of truth provides own management mechanism for all those stuff which is already implemented in MSI. And we usually want to avoid the situation when there are going to be 2 places where you can manage the inventory, Magento and the ERP system. Because in this way, we're supposed to support synchronization, like two-way synchronization from Magento to ERP and from ERP to Magento. So for example, regarding the MCOM, for us it's much easier just to switch off all the UIs and all the possibility of the inventory management in Magento, while we have this source of truth from the Magento order management point of view. That's why what we're supposed to do in this case, just disable all the modules with the admin UI suffix. That's all. And all the UI in the admin panel will just disappear. So this is how the headless. This is a pretty basic example of how the headless approach implemented in the new inventory mechanism. And here is, you can see the desirable state of the new modular system, where you can see that all the communication between all layers of the system happens via the API only, and any of the isolated component has own data storage. And the database split is also very interesting and very tricky stuff, because if we say that each of the components is supposed to use own data storage, we are not allowed anymore to use joins between different bounded contexts. We are not allowed anymore to use the foreign keys to guarantee the consistency of data. And actually, all the data consistency is supposed to be kept on the application level. And we already have the database split for the checkout and the order management in the Magento Enterprise Edition. But we're supposed to do it a little bit we're supposed to do the same stuff, but also introducing the same refactoring for the community edition as well. And this is what we done, for example, in the scope of the new inventory mechanism, when we don't have any interjoins between catalog and the new inventory database, and there is no foreign keys on a catalog. That's why, for example, we can proceed with the shipment of products which were already deleted from catalog. So this is our desirable state, like when the system would be deployed not in the scope of one system process, but in different isolated services. And in this case, after that, we can provide much better ability of scaling, because we can scale just particular components which we need to improve the throughput of, but not the whole system. Also, we have the Magento administrative tools, which is currently created, and also this QR code leads to this tool. So this particular tool provides you to manipulate and manage all the Magento instances on a different servers. And via this tool, you can give a command for deploy additional instances or shut down these instances. So this tool also would be developed and provide more and more functionality further. And the last but not the least is the Conway flow. So developing the code, you also your organizational structure also will be changing to correspond to this bounded context, and they're gonna be teams who will be responsible for particular functional areas, like we currently have, for example, in MSI, where we have domain experts. Some of these experts are not even Magento employees, and they know about MSI quite a lot, and they spread this knowledge, and they preventing the wrong fixes to be delivered to MSI. So all code changes regarding the inventory currently guarded by the guys who work on MSI. That's why we can achieve the much better code quality. And here is the plan regarding the service decomposition. So since Magento 2.3.0, we released Magento MSI, which can be considered as a pioneering project which correspond to the ideas of the service isolation I just mentioned. And here you can see stage by stage what's going to be released, the new components which are supposed to follow these principles further. And this is just a list of useful links to follow. The first one, as I already mentioned, probably the most important one, is a Magento Service Isolation Design document created by Anton Krill, Magento Administrative Tool, and of course MSI. I just couldn't not mention MSI, so I always use it as a useful link. And that's probably all.